So in my last video, I just executed the bootstrap code for this program, and now we can move on to the main part of this program. So we can see here in line 0, we have the instruction line function main.main 0. And then when I execute that, that doesn't actually change anything on the stack, so I'm not going to do anything on my whiteboard right now. But then we can move on to the next line, which is line 1, which is push constant 3. So I'm going to push the constant 3 onto the stack, again representing everything with index cards. And then again, this wraps around. So this starts at 256 right here with this 28. It goes all the way around. And then now we are at address 266, and that is where this 3 is. And so now I'm going to move stack pointer down since we pushed a card onto the stack, or we pushed a value onto the stack. So now I move my stack pointer down. And then we can move on to the next line of our instructions. So the next line of our instructions in line 2 is call Main.factorial 1. And so why don't we take a closer look at function calling. And then I can look at slide 117 from the lecture, right here, where where function calling is defined. And so I can look in this box right here, and that basically tells us what we need to do. And so the first thing that we need to do is called push return address label. And so we need to figure out what that means. Well, our return address will be the number of the line following our function call. So right now our function call is in line 2, right? So the line after that will be line 3. So I'm going to push a 3 onto the stack. And then I move my stack pointer down because I pushed a value on, so that is that 3. So this 3 corresponds to this 3 right here in our instructions. And it's just a coincidence that these two numbers happen to be 3. They're not actually related to each other at all. And so looking at how we define function calling again from the slideshow, so back from this slide, we have a bunch, the next 4 instructions can be grouped together. And the instructions that we have are push local, push argument, push this, and push that. And what that means is that we are going to take copies of the 4 values we have here from local, argument, this, and that, and push them onto the stack. So I already have these index cards written up. So first I'm going to take a copy of 266 of local. I'll push that onto the stack, move our stack pointer down. I'll take a copy of argument, which is 261, push that onto the stack, move stack pointer down, and I'm going to move this argument card just because it's going to get in your way, but I'll be returning to this in a few minutes. I'm going to take a copy of this, which is 0, push that onto the stack, move our stack pointer down, and then the same thing with that. I'll take a copy of that and push stack pointer down. Push stack pointer down, push stack pointer up. I think you know what I'm saying. So that is those instructions of handling call, but we still have a few things left. We have the instruction set argument is equal to sp minus 5 minus n args. And it means reposition arg. That's the comment that we have there. It says reposition arg. So that means that we want to reposition this thing, this kind of point, this arrow right here, we want to reposition this, and then we want to change this number. But because these two things are the same thing. This 261 is where this was pointing to right here. And so the question is that we need to answer is, where do we want to put this now? So we can look at that. Right now it says sp stack pointer minus 5 minus n args. So right now we have stack pointer. It is currently at address 272 because this is 266, 267, 268, 269, 270, 271, 272. So we go back 5, minus 1, 2, 3, 4, 5, and then minus n args, which is our number of arguments. And we know the number of arguments for this function based on this number right here. We have call Main.factorial 1, and this 1 tells us the number of arguments that we have. So for this function, we have one argument, and that argument is 3, because we are taking the factorial of the number 3. So I'm going to put this argument, I'm going to put that right here, because that's where it goes, and we're going to take care of this next. But this argument right here points to this 3, and so now I am going to overwrite the argument that we have here with the 272. Wait, no, my bad, wrong number. I'm actually going to rewrite with a 266. That's right, 272 comes later. Because this is a 266, this 3 is in RAM address 266, and so that's where argument points to. This is pointing to 266, and that's why that's 266. So our next instruction is to set local to where stack pointer is, and right now our stack pointer right here is pointing at 272. So I'm going to overwrite local with 272, and then put local where stack pointer is. So now these two things are pointing to that same empty spot. And then our two more lines in the assembly code for function calling. The first one is go to function main, and all that means is that in our instructions we're going to jump from line 2 down to line 4, because in line 2 we call main.factorial, and in line 4 is where function main.factorial is, so we just jump from line 2 to line 4. And then the last thing is that we create a return address label in our assembly code. But since this is in the assembly code and it's a label, it doesn't actually affect our stack, so there's nothing for me to do here on my whiteboard. And so that covers function calling. And in the next video, I'm actually going to start executing this factorial function.